Hello, good evening. Good evening, everybody.
Good evening.
All right. I want to welcome all of you to the platform and respectfully request that we show some commitment to the program. The desire is that everybody who participates in this program gains some knowledge, first and foremost, to enable the person to pass his or her lancashire exams with ease, and then also get some information that will be important even in practice. We don't want a situation where people will just subscribe to a program, yet will not attend the class. If you do that, then I don't know what you want to achieve, because if registration will not guarantee you a pass, the fact that you have registered to the program will not guarantee you. You definitely have to attend the program, listen, and then ask questions. And then all of us will share some knowledge together. And that we hope will enhance your chances of passing through your exam. So please, it is very sad that people will register, will not attend meetings, or will not attend lectures. And when unfortunately you are not able to make through, you begin to criticize the program. I'm not sure the program is bad at all, but if you don't put in the best of the efforts, there's very little anybody can do to help you. So please tell your colleagues who have signed on to the program to actually also make time to attend. If you think that the timing is not appropriate for you, let us all agree, and then we will adjust. I'm talking about the facilitators. We are very committed to helping you. So if you think the timing too is not good enough, you can all of us discuss. Then let's come to a compromise and say that set times will be more appropriate. Then whether we like it or not, we will now also try to adjust ourselves to meet your demand. So please, this an appeal to all of you. If you think the timing is not good enough, let us all discuss and come to a compromise so that once we start, at least we get the maximum numbers. That will also encourage all of us. We don't want to be talking for the sake of it. People must listen. And for me, if you don't attend the lecture, I'm not providing more than, I don't know how to put it, but I'm not going to provide a lot of slides for you to share with your colleagues. And then also, so if you don't attend the class, trust me, you lose out, because the number of slides I present is virtually nothing to write home about. It's the talking that will help all of us. So please tell your colleagues that we are committed to helping you. The only way you can also show that commitment is to show presence in class. So meanwhile, is there how many of you were part of the previous program, the first program that was held? May I know how many of you, if you can show by hand on the platform, how many of you actually were part of the first program? If you can please show by hand whether all of you are new or some of you were part of the first lecture or the first program. I'll be pleased to know that. Okay. So far, I'm seeing only one hand up to indicate that there's only one person who was part of the first program. I'm sorry that you couldn't go through. It's all part of life. A failure is not the end of anybody's. It's not the end of life. So it's also a learning curve. So if you went through the program, yet you couldn't make it, we are sorry for that, but I'm sure that it's been a learning curve for you too. So sorry for that. We pray that this time around, all of you will be able to go through successfully. All right. But once you have made a first attempt and couldn't make it, doesn't bring the work to an end for you. It is still part of the learning process, and you should take it in good faith. All right. Good. On that note, we will try to do something for today, very short one as an opener. And then subsequently, we gear up. Okay. Right. And don't hesitate to draw my attention if there's something you want to ask a question about. Please, we are here to solve problems. Either some of the problems you have come across, which you want us to discuss and see the best solution, or anything that will assist you in your preparation this time around. So please, we are all together. So we start. We've said some of the basics in microbiology. Any microbiology that you start, you have to know about certain basic stains that are used in the lab. And sometimes some of the questions they'll ask will be about some of these stains that we're talking about. So you begin with gram stain. All of us know that microbiology begins with gram staining. And for gram staining, I'm sure basically you know that you need a primary stain, which you call a crystal violet. You need a mordant, which you call an iodine solution. But basically, the iodine solution, you have various types. The one which is now used in gram staining is called grams iodine. And grams iodine is prepared from what we call Lugos iodine. Lugos is spelled Lugol''S, Lugos iodine. So, and frankly speaking, the original gram stain used Lugos iodine. Currently, the modified gram stain, which all of us are using now, uses the grams iodine. So grams iodine is 1 in 3 dilution of the Lugos iodine. So what it means is that if you have Lugos iodine, you don't use it straight as your mordant in the gram stain. You will make a 1 in 3 dilution. What it means is that if I take 1 ml of my Lugos iodine, I have to add 2 ml of water so that my final dilution is now 3 ml. So out of the 3 ml that I'm getting, the portion or the proportion of Lugos iodine in the 3 is 1. So that's why we call it 1 in 3. So if I have 10 ml of Lugos iodine, it will be diluted to become 30 ml of grams iodine. If I have 50 ml of the Lugos iodine, it has to be diluted to become 150 ml of grams iodine. That is what you'll be using for your gram staining. All right. So I'm sure by this time we all know about how to do gram staining. Sometimes they ask questions to also elucidate how you understand the principles of a gram staining. The gram staining is a test for the cell wall integrity. That is, the structure of the cell wall determines your gram staining reaction, whether it's going to be gram positive or gram negative. It is going to be determined by the structure of the cell wall. So I'm sure that you remember in school that we have what we call gram positive cell walls and gram negative cell walls. Okay. So when we talk about gram positive cell walls, we are talking about that cell wall with a lot of peptidoglycan. Okay. Now, and very little of lipid in the gram positives. There's so much of peptidoglycan and very little of lipid. It is the opposite in gram negative cell walls. In gram negative cell walls, there's very little of peptidoglycan, less than 10% of the cell wall is peptidoglycan. And then the rest is made of lipids. So we have what we call lipid bilayer. That is 2 layers of lipid. All right, so in your gram staining, you realize that you first and foremost apply your primary stain, which is the crystal violet. And then after that, you apply your mordant, which is the iodine. I'm saying here now, the iodine is grams iodine, okay? You use the grams iodine. The crystal violet will complex or will add itself to the iodine to form a molecule. Now, the next stage is to apply your decolorizer, which is acetone alcohol. Remember, previously we were using only acetone for your decolorizer. You know that in the absence of acetone, you can also use alcohol. But now what has been proposed or what is being used now is a combination of the acetone and the alcohol, because the acetone is very fast in the decolonization process and the alcohol is very slow in the decolonization process. So if you mix the two, one is fast and one is slow. If you mix the two, then you get a moderate decolorizer. So contemporary or the modern gram staining requires that you use a combination of acetone and alcohol. So it becomes acetone alcohol. Whatever, this is to dissolve lipids. The main action of the acetone and the alcohol is to dissolve lipids. So you see that in the gram positive, there's very little amount of lipid. So if you apply the decolorizer and it dissolves the lipid proportion is so small. So therefore, the primary stain which you apply with the mordant is still unable to move out of the cell wall, because the cell wall is still in this active or compact state, so that it is not going to leak out the primary stain. Now, that is so the primary stain becomes more or less entrapped within the bacteria. So that entrapment will give it the color at the final stages. The final stage color will be a combination of the violet color and the brown color of the iodine. So the violet plus the brown will now give you some blue coloration. That is how come gram positives stain blue. It's a mixture of the violet and the brown color to give you blue. So if you have a blue coloration, it means that it is gram positive. And it means that the bacteria was able to retain that primary stain. Now, on the other hand, on the flip side, you get the gram-negative cell wall, which contains a lot of lipid. Because it contains a lot of lipid and less of the peptidoglycan, if you apply the decorizer, and I've told you that the decorizers will dissolve lipids, and since the gram-negative have a lot of lipids, then it means that once the lipid is dissolved, it opens up the cell wall. The cell wall is now like empty. Okay. Once the cell wall has been made almost empty because of the dissolution of the lipid, then the primary stain, which was used initially, will now escape because it's like the cell wall membrane has been damaged. Okay. Once the cell wall contains a lot of lipid and the lipid has been dissolved by the decorizer, then it means that the floodgate has been opened. So now the primary stain will escape. So sometimes they ask questions, especially at the diploma level, they ask questions like, after the in gram staining, after the decorization stage, what will be the color of your gram-negative organisms? Okay, so from the explanation that I've given, it means that after decorization stage, gram-negative organisms will stay colorless because the decorizer has dissolved the lipid in the cell wall. And once they have dissolved the lipid in the cell wall, and the cell wall contains so much of the lipid, it means that the cell wall gate, let me put it in quote, the cell wall gate has been it's like it's now open. So the primary stain will escape. Once the primary stain escapes, what it means is that the organism will not stain and will be colorless. So if they ask you a question like that, you should be able to know that after the decorization stage, the organism, the gram-negative organism will stain colorless. However, after decorization stage, gram-positive organisms will stain blue because they are retaining the violet color and the iodine. They are retaining them, and the violet and iodine combined will give you a blue color. So it means that after decorization, gram-positive organisms will stain blue, whilst they will stay colorless after, in the gram-negative organisms. Okay, I hope that point is very clear. Right. So after the decorization, the next thing is to apply your counter stain, which is either safranine or neutral red. Now, if you apply the safranine, it is only going to stain the gram-negative organisms because the gram-positive organisms they are already retaining the primary stain. Because they are retaining the primary stain, it means that they don't have space for the counter stain. However, in the gram-negatives, the stain have already escaped, and therefore the organisms is now colorless. Then they will pick up the counter stain. That's how come gram-negative organisms will stain red. I hope that point is clear. Good. They can ask you a question like, if you stain neutrophils, or if you stain cells that contain neutrophils, and the neutrophils, the nucleus of the neutrophils are staining blue, what is wrong? What has gone wrong? Can anybody explain this to me? If it is sorry, if you come across a question like this, that you made a gram stain, and the nucleus of neutrophils were found to stain blue. What has gone wrong, or what will you do? Can anybody share with us the explanation? I hope you are all listening to me. Hello? Hello?
We are listening to you, Grandpa.
Yes, please. So I'm asking a question that if you do a gram stain and the neutrophils, the nucleus of neutrophils are found to stain blue, what is the problem? Or how will you explain this? All right. So if you come across a question like this, what it means is that you know that neutrophils don't have cell walls. I've explained that it is the cell wall that will actually determine whether an organism should be gram-positive or gram-negative, okay? And then even if it's with a cell wall that contain less lipids will stay gram-positive because they have less lipid. The decolorizer will only dissolve the lipids and then try to create holes within the cell wall. But if the cell wall contains too much of lipids, as you'll find in the gram negatives, then they will create a lot of space within the cell wall, and therefore the primary stain will escape to now take over the counter stain. Now, if you understand from that angle, then you see that neutrophils, as we have in human cells don't have cell walls, and therefore neutrophils will not have a cell wall. If neutrophils will not have a cell wall, it means that automatically neutrophils will stain gram negative. I hope that you are following me. Neutrophils, they don't have cell walls. It means that neutrophils will stain automatically gram negative. Staining gram negative means that they will pick the counter stain, which is red, so that you expect neutrophils, both the nucleus and then the entire cell, you expect them to stain red. So if now the neutrophils is staining blue, okay, then what it means is that it is retaining the primary stain. The only way a cell like neutrophils will retain the primary stain is only when there was under decolonization. It means that you didn't decolonize well. If you don't decolonize well, the decolonization is to allow time for the decolonizer to take off the primary stain. Okay, but if you don't do it that properly, if you do it very sharply, then what it means is that you don't have enough time for the decolonizer to perform its work. So what it means is that there was under decolonization. So a question like this is just trying to test you whether you understand the principle of gram staining. All right. So thank you. I hope that if you meet such a question anytime, anywhere, you'll be able to explain. All right. And let me also say on gram staining, it's saying that whatever happens that will try to let the cell wall lose its integrity, then automatically the gram reaction will be negative. Okay, because the cell wall should be able to retain the primary stain. All right. So anything that will try to compromise the integrity of the cell wall will allow the primary stain to leak off. An example is this: if you have an old culture, okay, if you have an old culture, you have a plate, and you allow the plate to stay on the bench for about 3 days, and then now we are going to do gram staining. What will happen is that after 3 days of the culture, the organisms are beginning to die. Okay, once the organisms are beginning to die, it means that the cell wall integrity will have been compromised. For a cell to die, its cell wall will break up, so that it is no longer that kind of the structure that keeps the cell wall intact has been compromised. So what happens is that if you're doing a gram stain, if the organism is even originally gram positive, remember that the cell wall has been damaged because it has been allowed to stay there for a long time. The organism is losing its viability, and therefore its cell was breaking up. So once the cell was breaking up, if you do the gram stain, after applying the counter stain, because the cell was already broken up, still the primary stain will leak out. And once the primary stain leaks out, it will now pick the counter stain and now behave like a gram-negative organism. So those are some of the times they just want to make sure that you understand the principle of the gram stain. So that's how sometimes the person will be paying. That if you have an old culture, okay, and a culture plate and a gram stain is performed, what is likely to happen? The likelihood is that all the organisms will stay gram negative, whether they were previously gram positive or not. All of them will stay gram negative. Now, if you can also meet a question like this, that, oh, you have a culture plate and accidentally you put on phenol or bleach, okay? You put bleach or phenol onto your culture, and then immediately you try to retrieve it. If you do gram stain on it, remember that the bleach or the phenol will try to kill the organism. You know, it is a disinfectant, a very strong disinfectant that we use in microbiology lab. So if you put bleach or Lysol or phenol on your culture plate, and even you retrieve it and then you try to do gram stain, automatically they become gram negative because the bleach or phenol will try to kill the organism. And the first, if an organism is going to be killed by a disinfectant, the first thing they will attack will be the cell wall. So that means that they will begin to break up the cell wall. As soon as that happens, and you also do a gram stain, automatically you said that gram stain is a test of the integrity of the cell wall. So once the cell wall integrity has been compromised, then automatically the organism will stay gram positive, gram negative, irrespective of whether it was originally gram positive or gram negative. It will automatically stay gram negative. So that is the way you have to understand gram stain. Gram stain is very simple. But if you don't understand the principle, they ask certain questions and you may have difficulty in answering them. Look, we have organisms such as mycoplasma and chlamydia. Mycoplasma and chlamydia, they don't have cell wall. By nature, they don't have cell wall. Okay, so we say they describe them as cell wall deficient bacteria. Cell wall deficient bacteria. So if they don't have a cell wall, by nature they don't have cell walls, then it means that automatically they will stay gram negative. Because we have said that when the cell wall is there, then if that cell wall has a lot of peptidoglycan and less of the lipid, that's only where the gram reaction is going to be positive, because that cell wall is going to retain your primary stain. So if you have organisms such as chlamydia or mycoplasma that are cell wall deficient, they themselves naturally do not have cell wall, then automatically you expect that by default, they will stay gram negative. Okay, so if you come across a question which says that, oh, mycoplasma stain well on a gram stain, you see that that question is problematic. Okay, they don't stay well, they stain by default in gram stain. So that is the way sometimes they ask questions about gram stain. And I'm sure that with this kind of brief, any question that's related to gram staining, you'll be able to answer it with ease. Okay, right. Do you have anybody with any questions so far? We want to make sure that you understand these things so well that if they ask you any questions about some of the things that we are discussing, you should be able to have it easy to go. or no matter how the question will be twisted, you should be able to solve it. Is there anybody who wants further clarification on what we have discussed so far? All right. So the next is the nursing. The nursing is an attempt to stain organisms that have what we call waxy cell walls. And the typical example is the mycobacterium. You see, mycobacterium, you know that they are so called because they contain a lot of mycolic acid. That's the mycolic acids. And this mycolic acid is described as waxy. When you say something is waxy, we are not saying it is wax. What we are saying is that it is like wax. So we say it's waxy. And if you cast your mind to histopathology, you see that in the embedding procedures, we use wax. And wax has the nature of candle. Okay. So if an organism has a candle-like cell wall, then what it means is that it's going to be when you know that when you have a candle, it's difficult to allow water to pass through. So it means that such organisms will be difficult to be stained by gram stain because gram stain is basically aqueous. It is water-based. So if it's water-based and you have an organism whose cell wall is waxy, then it's not going to be able to penetrate and go inside. All right. So the nursing technique employs carbofuchsin. And carbofuchsin is a mixture of phenol and basic fuchsin. Basic fuchsin and phenol. In fact, phenol is a trade name. So the actual chemical in phenol is carbolic acid. Carbolic acid. So it's the carbolic acid which combines with the basic fuchsin to form the carbofuchsin. Carbofuchsin. So the Z10, the primary stain in the Z10 is carbofuchsin. And the carbo is coming from carbolic acid. All right, good. Now, all of us know that if you have candle, its antidote is heat. If you apply heat to candle, it will melt. As soon as it melts and you apply water to it, it will reform. So that's the principle behind the nursing. So in the nursing, when you have a smear, all right, and you put on carbofuchsin, which is the primary stain, then you apply heat from below. If you apply heat, what happens is that the cell wall, which is waxy, will begin to soften, okay, because it is waxy. And we know that candle will soften or will melt on the heat. Then it means that the cell wall of the mycobacterium will become soft. As it becomes soft, the carbofuchsin, carbolic is acid, and acids have a tearing effect, so they will penetrate into the mycobacterium organism. Once they penetrate, you see the next stage is to now wash your slide. If you wash your slide, you're going to do so with water. And so once you do so, the cell wall will reform, because we said that when you have waxy nature, something which is waxy, and you apply heat, it will melt. And later on, if you apply water, it will reform. So with the ZN, because you apply heat first, the cell wall around the mycobacterium will melt or will soften, and then the stain will penetrate. The next stage is to wash. As you wash, you are applying water. Then the cell wall will reform. As soon as the cell wall reform, it will capture the stain which have already penetrated. So as we explained with the gram stain, that the primary stain will be retained, okay, will be captured within the cell wall. Similarly, when you have the ZN, after applying your water, the cell wall will reform and then also entrap or capture your carbon fixing stain. All right. So after that, if you apply your decolorizer, which is 20% sulfuric acid, if you apply the decolorizer is not going to be able to remove the carbon fixing which has already gone inside the cell, inside the bacteria. So we are saying that the bacteria is holding on fast to the stain. So the word acid fast stain is just saying that in the presence of the acid, the bacteria or the bacteria is holding on fast to your primary stain or carbon fixing. That is all. So once it is holding on fast to it, it means that the organism will stay red because the carbon fixing is red in color. So once it is red in color and it has been entrapped within the organism, then we expect the organism to stay red. All right. So after that, then you are going to apply your counter stain. The counter stain is either methylene blue or malachite green. Okay, methylene blue or malachite green. And so that is the whole principle of the ZN stain. What you have to know is that the main organisms, the mycobacterium, the main organisms or the main strains of the mycobacterium that causes a lot of diseases are the Mycobacterium tuberculosis, which causes tuberculosis. The Mycobacterium leprae, which causes leprosy. So in examination, for example, they will just mention, you know that tuberculosis is also called the Koch's disease. So they will just want to find out whether you know that tuberculosis is called Koch's disease. So they can ask you that, in the diagnosis of Koch's disease, when you are doing your Z10, blah, blah, blah. So they will just, instead of just saying sputum straight away for you to know that sputum, you are dealing with tuberculosis, they can just twist it and make it Koch's disease, just to find out whether you remember or you know that Koch's disease is the same thing as the tuberculosis. Similarly, with the Mycobacterium leprae, all of us know that Mycobacterium leprae causes leprosy. And leprosy is the Hansen's disease. You understand? So the question, instead of probably mentioning leprosy, they can talk about Hansen's disease. If you talk about Hansen's disease, then they want to know whether you know that Hansen's disease is leprosy. All right. And it will be caused by Mycobacterium leprae. Then the next species of Mycobacterium that also causes serious disease is Mycobacterium ulcerans. Ulcerans is spelled ulcer, U-L-C-E-R, and then A-N-S. So ulcer, and then add A-N-S. So it becomes ulcerans. So Mycobacterium ulcerans causes a disease called the Bruley ulcer. I'm sure you have heard about Bruley ulcer before. So Bruley ulcer is caused by Mycobacterium ulcerans. Leprosy or Hansen's disease is caused by Mycobacterium leprae. And then Koch's disease or tuberculosis is caused by Mycobacterium tuberculosis. Since all of them are the main organisms in Mycobacterium, it means that all of them, if you want to stain them or detect them, you have to use the ZN. Because we said that the Z10 is the only stain which can penetrate the waxy cell wall, okay? The waxy cell wall of the Mycobacterium. The note here is that when you're dealing with Mycobacterium leprae, it has been known to be a weak acid fast. We have said that in the AHPC, your decolorizer is 20% sulfuric acid. All right. Now, with the Mycobacterium leprae, I'm trying to say somebody. Okay, I think somebody have put on. All right. So, Latif have put on the staining procedure for your ZN. All right. So the ZN is just applying the principle of how to deal with something which is waxy. If the thing is waxy, it means that it cannot be penetrated by water. And the only way out is to apply some heat. Once you apply heat, it becomes soft. Now the stain can penetrate. After penetration, you will have to now wash with water. Once water gets onto the surface of a molten wax, it will reform. So once it reforms, it entraps the stain. And once it entraps the stain, it has captured it in a manner holding on fast to it. That is the acid fastness. All right. Good. So what we are saying here is that with the Mycobacterium, we have the Mycobacterium tuberculosis, Mycobacterium ulcerans, Mycobacterium leprae. If you come to Mycobacterium leprae, it is less acid fast. So because it is less acid fast, we do what we call a modification of the stain. So the staining method or the staining procedure will use 20% sulfuric acid as a dechlorizer. Since you're dealing with Mycobacterium leprae and it is less acid fast, it means you must modify the strength of the acid to as low as 5%. Okay, so you have to reduce or dilute the 20% sulfuric acid to as low as 5%. So if they give you a slide and the slide, it says it's a suspected case of Hansen's disease, and you are studying it, then they expect you to know that, oh, if it is Hansen's disease, it is caused by Mycobacterium leprae. And Mycobacterium leprae is less acid fast. So while doing the ZN, at the stage where I have to apply 20% sulfuric acid, I rather have to modify or dilute my 20% sulfuric acid to 5% to be able to allow this the organism to retain the acid fastness. So that is how we expect you to understand the whole principle. And once you understand that way, any question that comes in, I'm sure you'll be able to deal with it. There are also certain organisms which are not Mycobacterium. They are ordinary bacteria, okay? They are ordinary bacteria, yet they are able to behave. They are able to also retain the carbofixin, all right, in the ZN. So they say they are also acid fast, even though they are not, they don't belong to the Mycobacterium group. And typical examples are Actinomyces, then Nocardia. These are typical organisms that are not Mycobacterium, yet they are also acid fast. So if they ask you questions, let's say, okay, which of the following organisms will stain by stain positive or are acid fast, then you should know that apart from the Mycobacterium, we have Nocardia, we have Actinomyces, which are also acid fast. The important thing to know is that, yes, Nocardia and then Actinomyces are all acid fast, but they are also less acid fast. So if you're doing your ZN and you are suspecting Nocardia, for example, you have to modify the strength of the acid from 20% to as low as 1%. Okay, that's how we do it. So if you are suspecting cases of Nocardia or Actinomyces, you know that they are also acid fast. So you do your ZN, but in applying your acid, you dilute the acid to as low as sometimes even 0.5%, and then you do your ZN. Then you are going to see that they show positive for ZN. There are also certain organisms which are not bacteria, but they are also they belong